Good afternoon, everybody. Today is ASB's first webinar. Thank you for joining today's presentation entitled Sanitary Design of Food Processing Equipment. I am Lynn Carson, and I will be your moderator for today's event. Before we get started, I want to review a few housekeeping items and let you know how you can participate in today's web event. We're looking at example of the GoToWebinar attendee interface.
Lynn? Oh, it appears we have lost our moderator. I apologize, everyone. Has some technical difficulties. So,
can you hear me now?
Yes, we can, Lynn.
Sorry, I don't know why that button keeps going off. But where did I leave off?
You were just introducing the attendee view.
Okay. So anyway, we're looking at an example of the GoToWebinar attendee interface, which is made up of two parts. The viewer window on the left, which allows you to see everything the presenter will share on your screen, and the control panel on to your right. Within that control panel is how you can participate in today's event. So let's look at that. By clicking the orange arrow, you can open and close your control panel. From the View menu, you can also set the control panel not to auto-hide when inactive if you prefer to keep it always open. The audio pane provides audio information. By default, you have joined the webinar via mic and speakers. Click Audio Setup to select your computer, speaker, or headset devices. If you prefer, you can join the audio via telephone by selecting Use Telephone, and the dial-in information will be displayed, including an audio pin. If you would like to ask any questions of today's presenters over the phone, you must enter your audio pin in order to have your line unmuted. During the presentation, you have the ability to send questions to our webinar staff through the questions pane. Simply type in your question and click Send. At the end of the presentation, we will do a quick question and answer session to answer as many questions as we have time for. During the presentation, we may ask you to answer a question by raising your hand. This option is located on the Grab tab. We will address Q&A at the end of today's session, and as a final reminder, today's webinar is being recorded and will be posted to the ASB website's webinar page. Now, I'm pleased to present our speaker today, David Jones. I would like to welcome Dave Jones. Dave has over 30 years of food industry experience in a wide range of roles, the most recent being Group Vice President for Sara Lee Supply Chain, where he has worked for 26 years. With a diverse food background, accented with a skill set to solve problems with a lean manufacturing approach, Dave has positively impacted brand and business performance. Dave has a wealth of experience in a corporate engineering role, working with sanitation experts, equipment manufacturers, design-build engineering firms, and company officials to address equipment and facility sanitary design issues in order to mitigate food safety risk while pressing for continuous improvement. Dave is a member of the AMI Sanitary Design Task Force and a part of its technical committee. He is an executive member for Corporate Sanitation Sourcing Initiative and has championed food safety and design concepts for a new plant with commissioning programs. He also has experience in leading shelf life improvements and food safety troubleshooting projects. He is HACCP and SQF certified and has spent 5 years with Union Carbide's Food Science Institute involved with processing and packaging projects. Dave has a passion to drive food safety to a higher level through training and education. And here's Dave.
Thank you, Lynn, for the introduction, and good afternoon, everyone. Welcome to American Society of Baking Sanitary Equipment Design webinar. Today's agenda will include the following. The context of our discussion is really the essence of the importance of sanitary design. Sanitary design's continuous improvement journey. We will cover GMA's 10 principles of sanitary equipment design for low moisture foods, and wrap up with some key focus areas with regards to hygienic design. I do want to explain the slides used in the deck are for illustrative purposes to capture and provide context to the principles with real-world examples. There is no intent to commercialize any supplier or processor. The objective of sanitary design for the baking industry is to understand that it is essential to protect the product from contamination and achieve cleaning effectiveness at its maximum. Food production, like airline travel, is extremely personal and very important. Food safety and human safety are the highest priority and non-negotiable. Every decision made concerning a food production line or the construction of an aircraft has a material effect on food safety and safety respectively. It all starts with having equipment with the proper design in order to be successful. And let me repeat that. It all starts with having equipment with the proper design in order to be successful. Designers and reviewers need to be steadfast and proactive when addressing sanitary design to ensure that regulatory requirements are exceeded and the best available technologies are implemented to design, build, and operate cleanable equipment throughout its entire life cycle. Equipment must be robust and its cleanable results sustainable in order to be successful. Sanitary design, much like the airline industry, has to protect the health and confidence of the consumer, as well as protecting the financial health and reputation of the company. The public's expectation of air travel, like food, is that it will be 100% air-free, and safeguards are in place to ensure that this will be accomplished every time. Our focus on sanitary design also uses the scientific principle, a process discipline, and stringent set of guidelines and compliance to food codes to ensure our products are safe. HACCP, standard sanitation operating procedures, audits, good manufacturing practices, sanitary design checklist, and operator training are all part of the big picture. Passengers assume that the aircraft design, preparation, training, and maintenance are in proper order, and all parties involved have the wherewithal to execute a takeoff regardless of other internal and external forces. The protocols in place are supported by trained personnel guaranteeing the probability of success. Baked good consumers are the same. They purchase and consume products with the confidence that every portion they enjoy will be safe and wholesome. Sanitary design requires discipline and perfection to accomplish the intended results. The efforts put forth with sanitary design, like flying a plane, do not end when it takes off, but must maintain themselves throughout the process. The expectations on the onset continue through reaching the final destination. The application of proven science and flawless procedures are necessary to ensure a safe delivery of the final goods and service. Our customers also require this. All systems must predict success, or failure is eventually imminent. And the consequences of anything short of a three-point landing have serious ramifications for all parties involved. Food manufacturers and suppliers, like pilots, are expected to deliver acceptable results every time. When we fall short of perfection, failure can be a costly near miss, such as the one in the Potomac, or it can have much more grave consequences, including sickness and/or death. What can happen to anyone can happen to me is a quote by Muriel Rukeyser. The risk of foodborne illness is a reality. We are dealing with agriculturally based raw materials and ingredients that will support microbial growth and are susceptible to foreign contaminants. The Center for Disease Control, the CDC, projected in 2011 that 48 million cases of foodborne illness will occur in the U.S. that will result in 128,000 hospitalizations and 3,000 deaths. That is, 1 in 6 Americans will be impacted by foodborne disease. This is why sanitary design of equipment is so important. By definition, sanitary design is the application of design techniques that allow the time and effective cleaning of the entire manufacturing asset. Effective cleaning must be accomplished to an acceptable microbial, physical, and chemical standard evaluated by both subjective and objective means. It is important to understand that the entire asset includes both the equipment and facility to achieve the desired results. Proper sanitation is the applied science for the attainment of hygienic conditions, and hygienic design complements the creation and maintenance of the state throughout the entire production cycle. And the production cycle can be anywhere from several hours to several days based upon the manufacturing process. The food industry's heightened awareness on sanitary design has gained lots of traction in the last several years. In 2002, the American Meat Institute Equipment Design Task Force developed and posted the 10 principles of sanitary design for equipment manufacturers and processors. These principles have subsequently been adapted and modified by the Grocery Manufacturers Association and dairy industry accordingly in the last few years. The GMA principles for low moisture food best apply for most baked goods, and that is what will be referenced today. The risk of not being 100% perfect is shown in this slide. The food industry is familiar with high-speed, high-capacity production equipment capable of putting out hundreds of portions per minute and billions of portions over its life cycle. Let's put this in perspective. If you had an asset that produced 2 billion portions, 99% means that you would expect 20 million defects. 99.999% equates to 20,000 defects. I believe you get the picture. That perfection can be lost in a split second with the wrong decision. Another food safety paradigm shift for processors and equipment manufacturers is to think like consumers within regards to portions, not always necessarily in terms of pounds or units of output. Pathogens are the enemies that are invisible, silent, and deadly to people, companies, and jobs. The baking industry agrees that pathogens are the enemy and elimination is the goal. When dealing with pathogens, there is no acceptable limit in our products. Roy Gilmer from United Fresh Produce states, the stakes for a large company to have a food safety incident are huge. It can destroy a company. Something we've done in the presentation is we're going to have polling questions. So now I'd like to take you to our first polling question.
Good afternoon, everyone. You should be seeing a poll on your computer screen. If you could please take a moment to choose an answer. Just give you a few more seconds. All right, I am going to go ahead and close the poll, and I'm going to share the results for you. Dave, the following is the results of the poll. 7% say yes to the question, and 7 say no. I'm now turning the presentation back to you.
Okay, thank you, Amanda. The key word there is art versus science, and we do look at sanitary design as being a science-based curriculum criteria. Salmonellosis is an infection associated with the ingestion of the bacteria called Salmonella. This organism is a gram-negative, non-swarming facultative anaerobe that can grow from 5 degrees to 45 degrees Celsius, as low as a pH of 4.05 and a water activity of 0.945. The organism is known to be present in many of the raw materials that are used in the baking industry and can be introduced into finished goods in several manners. The bacteria can also come from soil, animals, and humans. Basically what this means is that Salmonella has a wide range of acceptable living conditions. While it may only survive in a production area, it has the potential to grow under the proper conditions. This pathogen is the most prevalent foodborne illness bacteria, and as reported from data from 1997 to 2007, has shown an increase in infections of 10%. A number of the most recent Salmonella recalls have been associated with peanut butter paste, ready-to-eat cereals, vegetable protein, snack products, nuts, and chocolate. And while a typical baking cycle is a thermal kill step for Salmonella, the potential for cross-contamination with raw ingredients, cross-traffic, and people mishandling is great. That is why zoning to segregate raw from finished goods and dry cleaning are so important and critical to controlling Salmonella in the operation. And as you can see, that some of the misconceptions are small amounts cannot cause a disease, and that does not affect low moisture products. And again, while the product may not necessarily grow in the low moisture products, the presence of is the threat. So let's go to our second polling question.
All right, everyone, I'm going to open up the second poll for you. And it is, cleanable is evaluated exclusively by subjective criteria that includes sight and smell. You could go ahead and choose your response. Give everyone a few more seconds. All right, I am going to go ahead and close the poll now, and I am going to share the results with you. Dave, our attendees responded with 8% saying yes and 92% saying no. Okay?
Okay, thank you very much. And again, the operative word there is that evaluation is both subjective and objective. Moving on, this slide is the pathogen control equation for food safety and shows that it is a comprehensive approach to managing pathogens in a production facility. Most importantly for today's discussion, steps number 4 and 5 outline the importance of sanitary design for equipment and facility and the interaction with sanitation procedures and controls. This is the good news and bad news on the never-ending battle to control pathogens in the processing environment. The bad news is that pathogens remain steadfast, resourceful, and deadly. The good news is we know how to address reducing the risk. As quoted several years ago by a food safety expert, quote, "With determination and science, we can reduce the presence of pathogens in the food chain." Okay. A little bit, we'll talk a little about the some early phases of design and bring you to a more modern state. The equipment started to scale up mass production equipment, but cleaning was often an afterthought. Materials were not compatible with cleaning procedures, and the size and scale of equipment limited its accessibility. Materials of construction were not ideal, and soft metals and painted and coated surfaces were commonplace. This early vintage equipment was primarily mechanical, and product protection devices such as metal detection and X-ray were not part of the overall system. The evolution of design improvements are apparent. As you can see, the manufacturing equipment has continued to improve with regards to hygienic processing. The materials of construction have changed from mild steel to stainless steel, limited painted and coated surfaces, and sanitation and maintenance considerations are much improved. The new equipment incorporates food safety, worker safety, and functionality, but still there is a lot of room for improvement. And while the improvements are apparent, the fine details are yet to be resolved. And as you can see, the design changes have continued to evolve. And some call-outs here is, if you'll note at the top, the catch points that are not removable and allow for product and microbes to build up. Machine guards are not removable, creating a point for infestation, and areas are not accessible. And hard-to-reach areas that prevent adequate sanitation. Okay. Oh. Examples of sanitary design and improvements are shown here. But sanitary design does not have a destination. It's a journey that we continue to undertake. Better equipment to meet functionality and new ideas to enhance food safety will be ever ongoing. Here you can see the kick plate on the line and crossover sloped away from the product zone at the top left. Manual belt lifts to access the bottom of the belt. This provides cleaning from the top and the bottom, as well as sampling. And leg designs completely sealed off to prevent buildups and provide adequate clearance from the floor and equipment. Here's another evolutionary slide showing that other enhancements, such as the use of round stock or square stock turned on a 45 for equipment supports. And also you can see that the framework is completely sealed. No hollow tube, no chance of the tubes leaking. And some facility, and as we talked about, the plumbing and pipes and utility races with adequate clearance are both easy to inspect and clean, and also easier to maintain. So as mentioned before, cleanability of the entire asset is the goal. Here you'll see slope tops and maintenance enclosures with side penetrations, and in wet washdown areas the use of Nemaphore boxes. Minimal collection points and framework that's angled and turned on a 45 degrees and a much more open and modular framework. And sandwich joints minimized with proper offsets and clearance. Sandwich joints eliminated with adequate spacing of the mounting plates are shown in the picture at the right. The continuous improvement cycle is appropriately applied to sanitation design as well. This cycle of improvement is also known as plan, do, check, act when using lean problem-solving methods. As you can see, the evaluation of the designs with a checklist and identify the risks. You can create a plan and manage changes to ensure design flaws are addressed. And the checklist is also an excellent tool for communication. We can measure and improve and check against current cleaning methods to ensure improvements are upheld. And when applied correctly, sanitary design will not only improve food safety, but products will be made more efficiently at a lower cost over time. Applying the principles are evolutionary, not revolutionary. And the checklist that we will learn about today provides an excellent way to quantify the improvements and communicate with the appropriate parties throughout the process. Come on. Sanitary design requires a passion for perfection. FDA and USDA regulations require that equipment should be designed of such materials and workmanship as to be adequately cleaned and properly maintained. This requires that food processors and equipment suppliers understand not only what is to be cleaned, but also how it will be cleaned and under what conditions. Wet versus dry, type and amount of chemical, frequency, time frame are some of the questions to be considered. The next two slides outline GMA's low moisture food equipment design and facility design checklist. The principles included are guiding factors that will enable food professionals a greater assurance of defect-free product when these are implemented. Here are the 10 principles of equipment design. And this slide covers the 10 GMA facility principles as they apply to low moisture food production for the facility. Several key terms and references are listed on this slide. And as you'll notice through the discussion is that oftentimes we use different terminology. So I think it's always very important to make sure that we have a clarity on the terms we use. These call-outs are areas where significant bioburden, product, and microbial load may be found. But these are not all inclusive. It's critical to effectively communicate with all your team members involved in the process design, and the need to be very descriptive and have a clear understanding of your plan is critical for it to be successful. The upcoming checklist will provide you a tool to help educate your team. Some of those harbage areas are corrosive materials, rough finishes, sandwich areas, and we talk about a sandwich area, that's the interface of two or more materials that are not hermetically sealed, cracks and crevices, hollow rollers, poorly drained areas, spot welds, threads, lubrication points, dead spaces, a space where product can become trapped or retained. Control panels and equipment switches and power source are also high traffic areas for cross-contamination. So let's talk about the 10 principles. Principle number 1, food equipment must be constructed to ensure effective and efficient cleaning over the equipment's lifespan. A specific standard sanitation operating procedure, SSOP, can be followed to prevent physical, chemical, and microbial hazards to meet quality levels that have been validated by an active monitoring program. And this, again, is using both subjective and objective means to determine what is cleanable. The second principle, materials used for equipment construction must be compatible with the product environment and its proposed cleaning methods. The material must be corrosion resistant, non-toxic, non-absorbent, mechanically stable, and as you can see here some pictures of something not quite mechanically stable, and easily to be cleaned. A key example of compatible materials is that we have found that cloth belts in food manufacturing are not acceptable. Accessible for inspection and cleaning. All parts should be readily accessible for inspection, maintenance, cleaning, and sanitation. Special care to address cracks and crevices is important, as well as using simple tools to assemble and disassemble equipment. Special call-outs for catch pans, open construction, and machine guards can also be seen in this picture. No liquid collection. No stagnant product buildup or liquid collection to harbor or promote bacterial growth. This is particularly important for wet washdown areas or working environments prone to temperature fluctuations or high humidity areas where moisture may condense. And here you can note the advantage of having slope tops and open designs to help prevent pooling and prevent drainage. And even though oftentimes we use dry cleaning methodologies, there are areas in the facility that will be watch-outs for moisture collection. The fifth principle, hollow areas eliminated or sealed. Hollow areas must be eliminated or permanently sealed, such as frames, whenever possible. Solid construction is preferred over hollow tubes, but if hollow tubes are of choice, then make sure that they're completely sealed. Sealing of electrical connections to prevent contaminant migration, and continuous welds, not attachments via drilled and tapped holes. And my history and experience has proven that press fits and shrink fits will typically fail over time. The sixth principle we'll talk about is no niches. No pits, cracks, corrosion, crevices, recesses, open seams, gaps, lap seams, bolts, threads, rivets in the design itself. All of this creates a very difficult area to clean. Smooth wells should be flush and free of pits and occlusions and corrosion. And the other watch out is with niches is make sure that we do not create tight corners that are difficult to clean, or they may trap food and materials. Some things to watch out for are internal and external angles that don't provide adequate space. No press fits or shrink fits like we talked about before, because basically these are subject to leakage, and dissimilar materials will separate over time. No fasteners in the product zone. And if you do need to use fasteners in the product zone, make sure that we're using a Loctite application. Minimizing exposed threads. Again, threads almost impossible to clean on a regular basis. Be on the watch out for non-removable gaskets, bolted joints, and again, tapped holes should be filled. Sanitary design operational performance. During normal production, standard methods of operation must be performed in such a way that does not contribute to unsanitary conditions for the harborage and growth of bacteria. Avoidance of spillage and effective separation of product contact and non-contact zones are important. To ensure hygienic operation, it's essential that the design take into account components and parts that will be touched by the operator and maintenance. And some things to be on the lookout for: hygienic design of your maintenance enclosures. Make sure that we have adequate floor clearance. Exhaust systems, and again, if you have exhaust systems, that there's a clear separation of raw and ready-to-eat exhaust systems. Buttons and control switches that are cleanable, not just simply cover them with a plastic bag. Avoid product buildup on utility runs, and as the picture on the right shows, position your utility runs definitely away from exposed product. And utility runs and races are extremely difficult, if not sometimes impossible to clean. Validated cleaning and sanitizing protocols. Procedures for cleaning and sanitizing must be clearly written, designed and proven effective and efficient. Chemicals recommended for cleaning and sanitation must be compatible with the equipment and the manufacturing environment. And here's where, as equipment manufacturers, the procedures are provided by the equipment manufacturer. Don't just wait to have the receiver or the plant tell you how it's going to be cleaned. You need to be proactive, as I said before, and go forward and make sure that we know how to clean the equipment before it's shipped and delivered. The equipment supplier, other areas to address is what needs to be cleaned and how. Is it a wet clean? Is it a dry clean? What cleaning process are used, and are there restrictions on sensitive components, particularly in the area of sensors or maybe electrical devices? How are your parts stored? Are they safely removed and stored during the cleanup cycle? Have you developed a parts cart? What maintenance tasks are required before and after cleaning and sanitation? And have some consideration for how will it be sampled for microbial, allergen, ATP. All of these need to be included in the validated process. The ninth principle is separate process wherever possible. Equipment should be dedicated between raw and ready to eat uses based on a risk evaluation that includes the potential for cross-contamination. Risk evaluation could include personnel traffic, employee welfare facilities, air handling equipment, and other situations that may cause HACCP-based risk. Physical separation is best whenever possible. And again, make sure that this complies with the HACCP program. And again, a great place to do a risk assessment. And there are some other visual management things that can be done in the separation, such as use of color codes. And again, focus on making sure that we have separation from what's product contact and non-product contact whenever possible. And the 10th principle is meet equipment and personnel hygiene and standards. All plant personnel, contractors, and visitors must be trained and required to follow plant hygiene and sanitation requirements. This should be compliant with the plant's GMPs and intended to be followed by all. This applies to having equipment cleaned prior to the delivery and installation. So this isn't just for the food manufacturer. This would be what goes on in the at the equipment manufacturer as well. And again, my coaching and as I'm looking to the people on this call, no exceptions under any circumstances. You don't want to make exceptions for principle number 10 when you're in the throes of equipment installation that might be under a close timeline or something that's of an emergency repair. This is extremely important that it's managed at all times. An example of the checklist. This is the attached slide that's an example of the checklist with the 10 principles. This checklist can be accessed via the Commercial Food Sanitation website, www.csannet.com, and we'll have that reference in the posted deck. This check sheet is designed to break down each principle into an objectively scored format. And special note that, as we've talked about this checklist is not just for new equipment, but is also to be used for used or existing equipment. And as you can see here, that you can rate things on a scale, and you can give it a point value. So again, you can drive it to an objective measure. And as you can see with this summary check sheet, the checklist is in Excel formatted to provide a recap of each principle and allow the reviewer the opportunity to quantify the continuous improvement and prioritize those key objectives. Acceptance is based on resources, ability, time, and cost to implement the controls. This is extremely useful, particularly to establish SSOPs that are equipment specific to ensure that operational sanitary performance criteria is met for both new and used equipment. So again, you have a tool, or you'll have a tool that you'll be able to use for not only looking at new equipment or proposed equipment, but also be able to help you troubleshoot and make sure that your SSOPs are cleaning the equipment that's currently in place. So let's move to our third polling question.
All right, I'm going to be opening up the third polling question, which is the Sanitary Design Checklist is a tool for food manufacturers and equipment suppliers to evaluate equipment and monitor progress. Give a few seconds for everyone to answer. All right, I'm going to go ahead and close the poll now and share the results. Dave, 83% responded yes to the question and 17% responded no.
Okay. Take a minute to talk about that. As if you can refer back to the slide on continuous improvement, the use of the sanitary design checklist can fall very well into the Plan, Do, Check, Act. So it gives you the ability, whether you're a plant engineer in maintenance, sanitation, operations, or general management, to monitor sanitary design over time. And so let me maybe to give you an example of how this could be used. Say you were building a new piece of equipment and you went out and someone was working with the equipment supplier and you rated a current piece of equipment and gave it a score, and you then took the new design and it was prototyped and you gave it a new score. You could benchmark the old versus the new, quantify it with your validated cleaning procedures, and be able to use that check sheet as a way to monitor your progress of sanitary design over time. Again, I think as we've tried to drive the use of the checklist to make sure that it does become quantitative, and the more people that you have that can use it and become knowledgeable in it, it will become a more effective tool to help drive change. So here you can see in the checklist summaries that things have been weighted, and again, as you look at the tool when you use it being Excel-based, it's very easy to navigate through.
Dave, we actually just gave that poll, so if you want to move over to the next slide.
Yes, okay. My mouse is a little bit slower than I'd like it to be.
Here, let me go ahead and move that for you. Oh, you got it.
Okay, there we go. Okay. Thank you, Amanda. This slide is managing food safety, and the iceberg is a very good example of how the application of the 10 principles of sanitary design can impact how we manage food safety. Visible at the top of the iceberg to all are the programs, the checklist, objective measures that monitor the performance, but the true enablers of food safety are below the waterline. And when we talk about the true enablers, we're talking about the behaviors, the mindset, knowledge, assumptions, habits, and culture that really help us move along the continuum of understanding food safety. And the key to effective sanitary design is to allow employees to perform the behaviors you want, prevent the behaviors you don't want, and create an environment where employees learn not only the how, but the why of food safety. Empowered people with the right tools and working in the right system will do the right thing when they know that they have a positive impact on the business. And as we've all learned is that the people that work in sanitation, the design engineers, the operation, we all have an equal stake into how safe our food is. A sanitation-centric integrated food safe supply chain could look something like this. Creating a safe food integrated supply chain requires the concept of sanitary design to be present throughout each phase of every project. This is important from concept all the way through to producing a final safe food product, thus creating an equal ground for sanitation to be considered with every phase of the project. The use of the score sheet can provide assistance with training and education, in addition to supplementing capital requests, and prioritizing maintenance projects are also some very good examples. So here, as you can see, when we talk about food safety and sanitary design, is that at each step of the way, again, we're planning, we're checking, we're acting as to how well that design is truly meeting the needs of the business. A manufacturing line example. Equally important to hygienic design is not only addressing microbial risk, but also covering the chemical and physical contaminants as well. And if you'll notice that just last week, there was a packaged cheese recall where wire bristles were found in the finished goods. The next few slides will give you an opportunity to look at equipment with a more critical eye and be aware and insightful to opportunities for improvement. Take a few minutes and again with the webinar, but again you'll see that these pictures are posted and you probably have pictures in your own facilities or in your own manufacturing site. But here you can see, note at the top the difficulty to access the top conveyor and the congestion that is present with rollers and guides, while the bottom two slides are much more open and present the opportunity to properly clean the conveyor. One significant call-out is that the reduced surface area of the sealed tubular design and the spacing that is allowed. And I believe that a valuable lesson for designers to remember is that cleaning time and effort are directly proportionate to the amount of surface area. My belief is that we need to strive for simplicity. Here we'll look at the tumbler input. And do you see any opportunities here? A couple of call-outs: non-compatible materials, stitch welds, niches galore, crevices, sanitary operational performance. Does the design prevent product buildup? And just think of fasteners. Here on the tumbler exit, again, a couple of pretty big call-outs. We can look at fasteners, and we talked about that before. Note the wing nuts, exposed threads, drive units over exposed product, stitch welds, and if you look at the exit chute, a large surface area that probably is stationary and not able to be moved at the exit end of the tumbler. And if you look at the tumbler itself, how would you clean that overhead spray bar? And I really like this picture because I believe that this is a good example of why cleaning and maintenance must be part of the original plan. The size and scale, in addition to the access and very tight corners of the fins inside the tumbler, and addressing these concerns after the equipment has been installed are usually very expensive propositions. Also probably some key safety issues as you really take a close look at this. And as we look at the conveyor, what can I say? You know, it's almost like what's wrong with this picture? Lots of places to start. Sandwiches, inadequate standoff, a closed framework, floor clearance, stitch welds, and again, the big chute on the left that is guarding the product going up the conveyor, how could that be removed and how do you clean the backside of that chute? So let's go to a polling question.
All right, I'm going to get ready to launch the next poll, and the question is the target pathogen for dry food processors to monitor their environmental programs is. Everyone could take a moment to select an answer. Just a few more seconds. right, I'm going to go ahead and close the poll and show the results. All right, Dave, 8% chose E. coli, 15% chose Listeria spp, and 77% chose Salmonella. No one chose the fourth choice.
Staphylococcus.
Yes.
Okay. Not really a loaded question. Typically in the dry areas, Salmonella is the targeted pathogen, but as in our world of continuous improvement and improved regulatory scrutiny, there are plants that are looking and facilities that are looking at a wider range, but it's typically Salmonella, but there is no real exact answer to that. Sandwiches and accessibility. We've covered an extensive amount of material in the last few minutes, but I'd want to discuss two key points of sanitary design, and to maybe just leave a few things in your mind as you think about this in the days and weeks to come. With regards to sandwiches and accessibility, my experience has shown that these two areas need constant attention and reminders due to the dynamic nature of our food manufacturing facilities. Equipment is purchased and installed, but it is not uncommon for modifications to be made while on the shop floor. The changes happen over time and present risk each and every time changes are made. So when we talk about sandwiches, we're not talking about your typical peanut butter and jelly or BLT. A sandwich, with regards to sanitary design, as previously mentioned, is a contact point between two materials that is not hermetically sealed. This is not exclusively an equipment manufacturer's issue, but plant maintenance and outside contractors also can have input here. But understanding this concept will go a long way to having people understand the risk associated by not addressing sandwiches. The buildup of materials in these very small areas is all that it takes for pathogens to establish themselves or to have a niche where you could have an allergen buildup. Another example of more sandwiches would be the piece that's overlaid. And again, when you look at this, a tremendous amount of surface area underneath to where you could get a buildup. It's not really readily removable. And how would it be removed and stored, and could a single person handle it? So again, these areas of sandwiches can happen in many different areas, and it just doesn't have to be a welded area. They can also be oftentimes when we lay something on top of one another. But again, not hermetically sealed. And the second piece, and while I like this slide, and I want to thank Dave Kramer, an old compatriot of mine, for helping me put this together. But there's some real common sense approach, and when it comes to accessibility, I believe that all of us have the opportunity to improve the working conditions and allowing cleaning to be performed without compromise. And when we talk about inspectable, we mean with close visual inspection. And as you think about this, if you can't see it, you can't reach it, you can't clean it, and you obviously can't sample it. And typically, this accessibility can become a formula for a crisis. And this picture tells a lot of stories, and oftentimes I've used as a caption to say, hey, look what I found, a floor drain, which times maybe not uncommon to have a floor drain stuck underneath a piece of equipment. But this is what we do. This picture captures the essence of what we do not want to happen. Readily accessible is a location that can be safely reached by an employee from the floor or platform or a permanent work area. And obviously here you can see that a very close proximity to the floor. So in summary, good designs and safe food production take planning, education, and communication. The baking industry and their suppliers need to rapidly evolve equipment design, installations, and cleaning capability to adapt to new continuous improvement mindset. And there are compelling reasons to improve designs to assure the effectiveness from a HACCP standpoint and a business standpoint. The industry, both processors and suppliers, must work together to advance the designs and work together to incorporate those best practices. I believe we need to take time to understand and apply the principles in the checklist and share this information with your business partners. Again, the more that we can openly communicate, the faster progress will take place. And all equipment existing and new should be evaluated using the principles and equipment design checklist. SSOPs should be developed knowing the risk and difficulty to clean specific pieces of equipment. So the benefits of sanitary design fall right in the middle. And that's achievable, repeatable, acceptable food safety results. No single principle overrides the other, but when implemented, good things happen in a predictable fashion supported by a very strong process discipline. And I love this quote, and I took it from an old safety manual, but the highest level of performance you will achieve is your lowest expectation. And I think that as all of us, we understand that we need to strive for the highest level of performance and understand we are working in a highly regulated food industry and selling foods for human consumption. And the more stringent food laws and improved sampling will continue, that our efforts are needed with sanitary design. And as you can see here, sanitary design is very similar to a successful landing. When it works as designed, all parties involved are satisfied. I thank you very much for your time and attention, and I'll turn it back to Amanda.
All right, everyone. Let me move forward. These are a couple of resources that Dave has provided for you, and I'm going to now hand it over to our moderator. We have a few minutes left for a question and answer session. Lynn?
Well, thank you, Amanda. Thank you, Dave, for sharing your insights on the sanitary design of processing equipment. We do have some time now, so we will allow some question and answers, if we have any. I'll be reading your questions aloud to David, who will then respond.
If you do have a question, you can go ahead and submit it in the chat section. We'll give a couple of seconds. All right, it doesn't appear to be any questions have come in. So Lynn?
Okay. So I think we'll close this webinar. Well, right then. Thank you.
Wait, Lynn, there is a question. I'm sorry,
Oh,
there is a question. Let me actually go ahead and unmute the individual. Sharu, do you want to go ahead?
Sure. Thank you very much for this very informative seminar, Dave. I wanted to understand what credentials, from a sanitary design standpoint, what credentials do processors out there value from a design build contractor such as the company that I work for is Burns McDonnell? What credentials do we want our employees to obtain so the processors value what we bring to the table?
Thank you for the question. While in the different industries there have been training sessions around sanitary design, whether it be the dairy industry. I know the GMA had sanitary design back in the spring in Milwaukee. I think the purpose of the use of this of the spreadsheet is probably a place to start, but in terms of actual accredited training around sanitary design principles, I'm not sure of what exists there, but if you do leave your name, I can get back with you.
Okay.
I do know that when we look at this, oftentimes when it comes to validating cleaning procedure, it was done on a plant-by-plant basis.
Mm-hmm.
I think if you look at the intent of the principles, they're really they're not as stringent as having accredited as they are as overall guiding tenets to help us build better equipment.
Okay. Very good.
All right. Sure, if you want to give me your additional information, you can email me at agonzalez@asbe.org, and I'd be happy to put you in touch with Dave if you guys want to discuss some more. However, we are at the end of our scheduled time. If anyone else has a question, either for myself or for Dave, please feel free to send me an email or give me a call. My contact information is on the screen. And we will be sending out a follow-up email with survey, and we would greatly appreciate it if you could take the time to complete that survey. Your responses will help us with future webinars. Now, I want to thank Dave and Lynn for volunteering their time to bring this webinar to you, and we will now be concluding the event. Dave, Lynn, do you have anything else you want to add?
No, thank you, Dave. It was a good seminar.
Thank you, Amanda and Lynn. Good day.
Thank you.